Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome back into the program. I hope that you're doing well and you are ready for today's show because what a week. It's been up, it's been down even more. Ladies and gentlemen, today's show should be a lot of fun for you because it's none of those things. Well, it's all up. And we have Ralph Bond joining us. He is our science and tech trends correspondent where, we talk about some fun things. We talk about bridges with barely any material. We talk about some vision tests that are, or I should say some vision improvements. We're going to talk about a number of different articles that you want to hear about. You might have missed them, or they are just in publications that you don't normally frequent, but Ralph does. And ladies and gentlemen, computeramerica.com, that's where you'll find everything, including the show notes, all of the links to the articles, all the research papers that Ralph can find. Ladies and gentlemen, these are great stories that you definitely want to hear about, so stay tuned for that. As I said before, computeramerica.com, that will have everything, links included. So if you're driving, if you're busy, if your hands are, you can't really follow along with the video, then hey, you can come out to the website after the fact and find everything that you could possibly need, including past shows. So with that being said, find us on social media, all that good stuff. Let's go ahead, bring Ralph on, and just have fun with it. So as I said before, science and tech trends, exactly what that means, he'll get into that. But Ralph, welcome back onto the program. How have you been?
It's great to be back, and I'll tell you another wild and wacky world of news. But what we do, let's explain this, especially for anyone who's brand new to the show, welcome, but let's explain what we do. Ben and I, each Friday, what we do is we highlight 4 articles that show us key trends and developments in all things science and tech, including almost every story. Not every story includes artificial intelligence, but we look at robotics, medical technology, sustainable energy technology, transportation advances, agricultural tech, construction tech, space research, physics. Wow, you name it, on and on and on. But here's the key, so important this week, as almost is the case every week. Most important of all, we're going to give you hope for a better future, thanks to amazing breakthroughs happening every single day in the world of science and technology.
Exactly. And once again, if you are following along with with the video, we appreciate that. We'll have the articles in the background showing demonstration videos and diagrams and stuff like that. But if you are simply listening, hey, it should be a totally listenable experience. We're going to do our best to describe everything. And you can come out to the show notes after the fact to see. So with that being said, Ralph, let's talk about, bridges and MIT. So this one looks really cool.
It is very, very cool. It comes from MIT News, their website, their outlet, their announcements. Headline, computer model could enable bridges and buildings that use less material. And the subhead here is MIT researchers developed an approach for generating more buildable structures, bridging, no pun intended, bridging the gap between optimized design and real world construction. And this is a really interesting story if you're an architectural or engineering and construction geek, which I was for 10 years when I was with Autodesk and served their architecture, engineering, and construction division. So I love this kind of stuff. But let's get into this.
Well, and just real quick beforehand, my local government also builds bridges with less material, but they just wait 30 years and it crumbles down, and it's the same bridge just with less material. So hopefully a different approach from MIT.
There you go. So MIT researchers have created a new computer model that could help engineers design bridges and buildings using much less material while still keeping them strong and safe. Since making construction materials produces more than 7% of global carbon emissions, reducing material use could greatly lower the environmental impact of construction. Now, the new MIT model improves a design method called, and I didn't know anything about this one. This is kind of cool. So it improves an existing design method model called topology optimization, which uses computers to find the most efficient way to place materials in a structure. Now, in the show notes, when you come to computeramerica.com, if you're listening to us, please come out and get the show notes. When you see blue text inserts, they're additional educational, most of the time for my benefit, information and so forth to expand on topics. Because again, the people who put these news announcements together in science and technology just assume, oh, well, you know what topology optimization is. Of course you do. No, I don't. So I went out and got some interesting additional information. And you can learn more about what is topology optimization. I'll give you a couple of bits here. It's a computational design method that determines the best possible material layout within a defined design space, given loads, constraints, and performance objectives. Now, a key point that I also inserted into the show notes, I immediately thought, oh, this has got to be an example of artificial intelligence, a large language model where they say, I want a bridge to span 150 feet. I want it to be this tall. I want it to be 2 lanes. No, this is not AI-based. It's a computational optimization model that uses mixed integer algorithms and topology optimization, but it does not involve machine learning or artificial intelligence. So when I was reading this article at first pass, I thought, oh, it's AI, of course. And I asked AI, is it AI? And AI said no.
Yeah, it's even more, or I'm sorry, it's even less understandable than AI. It uses math. So even scarier.
Even more scary. And then going on here, although this topology optimization method can reduce material use by up to 90%, whoa, traditionally, to date, it often creates complicated designs that are too difficult or expensive to build in real life. That's been the problem with this whole model. To solve this problem, the MIT team develops software that includes practical building rules. Again, not AI, not machine learning. It limits how many pieces can connect at one point, controls the minimum size of parts, and considers how different materials such as steel and timber behave. And this allows the computer to create designs that are both efficient and realistic to construct. And again, the show notes have some great illustrations if you want to check this out.
You know, this is sounding a lot like, for anyone out there who's a big fan of mobile games, there's a game out there called Polybridge 2. And, you know, I'm going to pull it up on screen real quick.
Oh, yeah, please do.
Yeah, this is essentially the game here, and you have to decide, you know, you're giving a constraint, a budget, you have like weight loads and, you know, different objectives for the bridge, and you select your material, be it steel or wood or whatever. And it's a whole game where it's just, you know, build a bridge with different materials and try to accomplish, you know, getting the car across the bridge. But actual real life and actual, you know, usable information and data. But yeah, sounds very, you know, sounds very gamified.
That's fascinating. That is so cool. What a great example here. So the researchers tested their system by designing bridge trusses using steel, wood, and combinations of both materials. That really struck me as interesting. They found that mixing materials can provide the strength of steel while reducing carbon emissions by using timber where appropriate. And that reduction of carbon emissions, there's a blue note or a blue text insert, talks about the impact of steel production in CO2 emissions. So this is very important. If you can reduce the use of steel and yet come out with something equally strong and durable by mixing in timber, wow, pretty cool stuff. And the program can also, and this is really important, this program the MIT crowd came up with can also run on a standard laptop, making it practical for engineering firms. The team hopes this technology will help designers create safer, lower cost, and more environmentally friendly infrastructure in the future. And Lord knows we need help in that department.
Yeah, and, you know, even more so for the amount of bridges that need, you know, kind of maintaining or even just new ones built completely. I'm sure, Ralph, you know, just back in the day, you were just like, okay, you know, build it out of steel, over-engineer it, and hey, you'll be good to go. But now it seems like they're moving into territory of, you know, build it. I'm sure it will be very capable. It'll be a good bridge. It's not going to break. They're not, designing it to the minimum, but rather they're just designing it to, I guess, like the appropriate amount. And
Yeah,
yeah,
right.
I could see how that could save a lot.
Yeah, and again, big takeaway for me was one, it's not AI based. Number
Hmm.
two, the whole idea of mixed media, mixing steel with wood, and saying, wood could do the job just as well and reduce cost and carbon emissions in production and so on and so forth. Wow, that part was fascinating to me.
Yep, and again, it's that topology that you were talking about, something that's been around for quite a bit, but in research labs, and they want to bring it out into the real world. So yeah, very very cool. So story number one. If you're following along, you can of course kind of go along as we go. But yeah, scrolling down to story number two, and we're going to talk about Ralph. I guess a trend that we have seen, and so honestly, some of the stories that really stick with me over time are materials and things that really repair themselves, make themselves last longer
Yes.
because they, and I'm sure you're thinking it too, the concrete with the algae, that kind of reacts to
Mm-hmm.
oxygen and
Mm-hmm.
heals itself.
Mm-hmm.
Material that can heal itself is always super
Mm-hmm.
cool. So story number two, very similar.
It is. It's just really fun. And this impacts millions upon millions of people who wear contact lenses. So here you go. This comes from bioengineer.com. Great website, by the way. Headline: Self-healing contact lenses activated by UV light. A breakthrough in vision care. Okay. We have a link, of course, to the article, and also in the show notes, a link to their research paper if you want to super geek out and get into this topic. So researchers at the Department of Chemistry at the Dankook, I hope I'm saying that right, Dankook. So the Department of Chemistry at the Dankook University in South Korea have developed a new type of contact lens that can repair itself when exposed to ultraviolet U or UV light. So nothing exotic, just exposure to UV light, potentially making future lenses last longer and reducing waste. Wow. Traditional soft contact. Well, let me try that again. Traditional soft contact lenses are made from hydrogel materials, soft, water-filled polymers that provide comfort and allow oxygen to reach the eye. However, these lenses can develop tiny scratches from everyday handling, cleaning, and exposure to dust. And of course, contact users know this. Once damaged, they usually must be replaced. Now, the South Korean scientists created a special hydrogel material that can heal itself using UV light. The material contains chemical links called disulfide bonds that can break and reconnect when activated by UV energy. Amazing stuff.
Yeah, the image that they use for the article kind of makes it feel like they're those UV guns that they kind of use for
Mm.
like whitening teeth and stuff like that. Yeah, just shine that
Yeah.
directly into your eye and it'll heal the contact lens directly on your eyeball. But no,
There you
I'm sure it'll be something much more safe than that.
Yeah, that's true. And so this process they came up with allows scratches and small damaged areas to gradually repair themselves. So it's not instantaneous, gradually repair themselves, almost like the lens is stitching itself back together at the molecular level. Okay. In laboratory tests, damaged lenses were exposed to UV light for about 1 hour at room temperature. The scratches were greatly reduced and the lenses regained their smooth surface. Researchers also added a protective coating that helped resist new scratches and reduce the buildup of unwanted materials on the lens surface, like dust, for example. The new technology could eventually lead to reusable contact lenses that are more durable, comfortable, and environmentally friendly. However, here's the reality check. These lenses are still in the research stage, and this gives me a chance to stress this for new guests to the show. A lot of the stuff Ben and I look at on Friday is early research in labs right now, not at Costco or your local pharmacy yet.
Yeah, it sounds like I okay, so I used to wear glasses, way back in the day. And I got laser eye surgery, never wore contacts.
Right.
But I will say the complaints, other than having
Mm-hmm.
to deal with them was, having to replace them so often. So, really
Mm-hmm.
alleviating one of those two big pain points, this seems great.
It would be amazing life change for many, many users out there. So to wrap this up, more testing is needed to confirm long-term safety, durability, and approval for consumer use. But if successful, self-healing lenses could represent an important advance in vision care by making soft contact lenses smarter and longer lasting. Pretty cool stuff.
Absolutely. So yeah, I hope that they can get this, kind of across the finish line, because Ralph, I could totally see, some kind of little apparatus that, you put your contacts lenses in overnight and it kind of, heals it back with some kind of light therapy. Or even, hey, maybe if they got this to an even more advanced level, maybe just the UV light of just walking around existing, just being outside could potentially, help its durability. So
Yeah, pretty cool.
very cool story. I like that a lot. Story number 2. Story number 3. We're going to go down, and this one might just have AI. And I pick up on that because the first word of it is AI. So,
Yeah, there you
Ralph, let's
go.
talk about pancreatic cancer.
Sure. Normally, folks, if you're new to the show, the fourth of the 4 stories we look at is medical technology. This week, I couldn't resist having 2. So story 3 and story 4 will be medical technology related. This first one, story 3, comes from the Mayo Clinic website, certainly a reputable source, to say the least. Headline: AI identifies pancreatic cancer years before diagnosis, offering potential for early or earlier treatment. Wow, this is so important. I love it. Researchers at Mayo Clinic in Rochester, Minnesota, have developed an artificial intelligence system that may detect pancreatic cancer much earlier than doctors can today, sometimes up to 3 years before symptoms or visible tumors appear. What? Wow.
That is such a disparity. And, you're going to get into all the details of the article, but
Right.
that's such a game changer for early
Oh my
detection
gosh.
and cancer survival rates.
Oh, yeah. And here's why. This is a major breakthrough because pancreatic cancer is one of the most deadly cancers, largely because it's usually found too late to treat effectively. So if you can catch this up to 3 years before symptoms or tumors appear, how many lives could be saved? Wow. That's so cool. The AI tool, called REDMOD, REDMOD, which of course is an acronym for Radiomics-Based Early Detection Model, studies ordinary abdominal CT scans and looks for tiny, subtle changes in pancreatic tissue that human radiologists often cannot see. These changes may signal that cancer is beginning to form even when the pancreas looks normal. Even when it looks normal. Wow. In testing, the REDMOD system, AI system, reviewed nearly 2,000 past CT scans from patients who were later diagnosed with pancreatic cancer. It successfully identified 73% of those cancers, an average of 16 months before official diagnosis, almost twice as often as expert radiologists reviewing reviewing those same scans. Wow.
I'm guessing that, obviously you're still going to have doctors and humans work into this whole thing, but I'm guessing if this system, obviously with more training and it finally gets rolled out to patients out there, it might just diagnose you and then kick you into kind of a more, okay, we need to be more aggressive on our monitoring of this. You might not have it, 73% is not 73 is not 100%, but
Right.
that might at least kick you up into a more, something we might need to watch out for and potentially
Exactly.
could save lives.
Exactly. Yeah. Treatment before it's too late with this capability is just such a great, profound thing. So to wrap things up, in scans taken more than 2 years before diagnosis, so scans that old, it found nearly 3 times more early cancers. And to wrap this up, the technology is still experimental, hence the bit about early research that we often stress. So the technology is still experimental and not yet FDA approved, but it could someday help high-risk patients get treatment much earlier, potentially saving many lives. So a profoundly important thing from Mayo Clinic. Thank you, guys and gals.
Absolutely. No, great research. And yeah, not to bring current news into it, but, if peptides can get approved, then, hey, maybe something like this can get approved as well. So we will certainly see. But no, it's really great. And I guess for a tech show, it's even more because you may have heard this guy, Steve Jobs. He wore a lot of turtlenecks.
Yes.
He unfortunately did pass from pancreatic cancer. So, just a little tech tie in there. Obviously, I'm sure everyone remembers that. But detecting it a couple of years earlier, and hey, the whole course of technology could have changed if we had a bit more Steve Jobs. So
there you go.
There you go. Okay, great story number 3. A lot of hope there. Story number 4. We're going to go ahead and move the show notes down there, and we're going to be talking about, well, a way to maybe extend aging. You're right. Peptide. No, not. And that's story number 3. Let's go ahead and scroll on down to story number 4. And this one's going to be really exciting because if there's one thing in the world that everybody hates, I haven't met a single person that said, I love aging into oblivion. That is the best thing in the world. Well, I haven't met that person yet. Story number 4 is going to be about maybe, potentially, curing aging, which is a big ask, but let's get into it.
Yeah. And believe me, I can relate. This whole thing about aging, I keep waiting for the golden years. No, the only part of the golden years for me is the gold leaving my wallet to pay for all kinds of stuff. But anyway, let's get into this. This comes from Scientific American, a wonderful, of course, very reputable source. Headline, get ready. Headline, world first therapy to make cells young again given to a person. And here's the subhead. The first participant has been treated in a landmark clinical trial of cellular reprogramming, which aims to rejuvenate aging cells. Oh my goodness. Of course, in the show notes, we have the link to the article itself, and it's going to be talking about a company in question. We have a link to that company as well, but let's get into this. In a historic milestone for longevity science, the first human patient has been dosed in a groundbreaking clinical trial testing a gene therapy designed to reverse cellular aging. Okay.
Yeah. I have a strong feeling it's not going to be just a simple, injection or flip of a switch. It's going to be a lot of things. But, it's going to be, this might just be one of those many, many things to reverse aging.
Exactly. And this is led by the Boston-based biotechnology company called Life Biosciences. And this phase 1 trial tests an experimental treatment called ER-100, which aims to safely reprogram aging cells back to a younger, more functional state. Wow, the breakthrough builds on Nobel Prize-winning research from a researcher, let me try that again. The breakthrough builds on Nobel Prize-winning research regarding Yamanaka factors, which are proteins capable of resetting a cell's biological clock. Now, as we've mentioned before, show notes, come to computeramerica.com. I've inserted a big blue tutorial text section because I went, Yamanaka factors? Okay, they think I should know this. All about proteins capable of resetting a cell's biological clock. But I went, nope, I need some help. So in this, I've inserted information about Dr. Yamanaka's discovery. He discovered a way to rewrite a cell's biological identity. It's very geeky. You can read more about that in the show notes. But going on, well, full reprogramming turns mature cells back into blank slate stem cells. This therapy utilizes partial reprogramming by introducing 3 specific genes. You're going to like this. Via a modified virus. We've talked about using viruses to do all kinds of things. Pretty neat stuff.
Yeah, and to once again utilize viruses, and it really goes to show, Ralph, that even this research that that they are referencing back in 2006 that won a Nobel Prize, very impressive. Here it is 20 years later, which
Yeah.
is no short amount of time, and they are continuing on with this research. And I'm sure AI definitely did play a factor in developing stuff, but by and large, research just takes time, and it's always amazing just how long it takes. But at the same time, Ralph, I guess if you cure aging, you can take as long as you want, just hey, so get this one little thing done, curing aging, and you can take as much time as you need to research everything else. So cool.
You got it. So to go on here, it says this research or this breakthrough resets the cell's epigenetic age markers, which are chemical tags on DNA that accumulate over time. And it does this without erasing their underlying identity or specialized functions. For safety, the trial, this I thought was so interesting. For safety purposes, the trial in question targets the eye, a highly contained environment. The therapy focuses specifically on retinal ganglion cells to treat age-related optic nerve damage from open-angle glaucoma, a leading cause of permanent blindness. Because altering gene expression carries the risk of triggering uncontrolled cell growth or cancer, researchers have implemented a unique molecular switch. The rejuvenation genes only activate when the patient takes the antibiotic doxycycline. I hope I'm saying that right. It's DOXYCY.
I think I've given that to my dog, doxycycline. So
so you're familiar. Okay, cool. So they've got this the safety switch. When you give the patient this, it will stop the process.
The doxycycline is like one of the most common antibiotics. So it's
there you go.
It's a very achievable, I guess, kind of trigger for this.
Yeah, pretty cool. So if side effects occur, stopping the medication shuts off the therapies we just noted. While the trial will follow up to 18 patients for more than 5 years to monitor safety and vision changes, scientists emphasize that this is not a cure for aging. Okay?
How dare they?
Instead, it's a critical first step to see if cellular rejuvenation can safely treat devastating age-related diseases in humans. So I really appreciated that qualifier at the end that this is not a cure for aging, because that would be like science fiction. But again, a nice targeted therapy that could be very helpful for many, many patients. And targeting the eye because it's sort of a self-contained environment, I thought that was very interesting as well.
Yeah. So even if it doesn't cure aging, which I was for the entire article, like, yeah, I'm all on board. Even if they just kind of reverse some of the diseases that are age related and you can at least cure these diseases. Even if you don't turn yourself back into a 20-year-old, this is still a huge breakthrough. And I'm sure for many diseases that were before considered untreatable, just a natural side effect of aging.
Right.
Potential breakthrough. Very cool story, Ralph. So story number 3 and 4, both medical news, and a great way to head out of the week. It's, medical news is some of the most uplifting and as far as technology goes, some of the most, really forward progressive stories that we could do. So, Ralph, I want to thank you so much for bringing all 4 of these stories. And ladies and gentlemen, if you are following along, you may notice, but Ben, you're only on page 7 of 12 of the show notes. Well, that's because Ralph includes a lot of extra work. We try to make him not work as much, but even though the show is condensed down into a smaller form factor, well, ladies and gentlemen, you have the honorable mentions. These are stories that if we had more time, we would totally talk about, but we just don't have that time. So instead, come on out to Computer America, scroll down to the bottom of the show notes, and you'll see the section called Honorable Mentions, and Ralph is at least going to give you the headlines, and you can come out, read, see more, and these are really amazing stories that you should know about as well. So go ahead, Ralph.
Exactly right. So we'll give you the headlines and the sources. Again, as Ben said, computeramerica.com. The show notes will give you all the links you need. So the first one comes from techexplorer.com. Headline, water locked in 1 nanometer channels could enable safer energy storage. This is one of the most curious energy storage research I've seen in a long time. Pretty cool stuff. So you got to check that out to understand what in the heck are they talking about here. The next one comes from really interesting source, trendhunter.com, like that. And this is kind of fun. Autonomous bee habitats. Hyve, which is YVE, so sort of a pun on the spelling of the real word hive, is a mobile beekeeping concept designed to support pollinator health. Okay, you've got to see the images of this roving beehive thing.
Even bees are going to get an electric car before I do. It's
yes, there you go.
and wow, this thing looks so kind of old fashioned, but at the same time super cool, futuristic.
It's a hoot. If you're into bees, this is for you. Okay, so the next one comes from eurekalert.org. Headline: Mining batteries in a microwave. Microwave-based method to upcycle old lithium-ion cathodes. Wow, another great recycling technology story. Check that out. Very interesting. And our last honorable mention is really very trend-oriented. Comes from BGR.com. Headline: This magnetic charging breakthrough lets electric ships recharge wirelessly at sea. Wow, Ben, in the world of shipbuilding, we've seen a lot of interest in sails to help augment very intelligent or AI-based sails. We've seen hydrogen hybrid with diesel and so on and so forth. This is really interesting, talking about electric vehicles and being able to charge them wirelessly at sea. Could be setting the stage for a breakthrough in the future. Who knows? Pretty cool stuff.
Yeah, it's, if you look at these industries, be it airplanes, be it cargo ships, be it whatever, be it ferries, and you just see, these big, massive chunks of carbon emissions, and that's what the industry is trying to nibble away at. How do we convert some of this and make it more sustainable and healthier for everyone? So everyone, that's our best attempt at an uplifting week, and we hope that you enjoyed the stories, we hope that you had fun, and you would come back for more, because Ralph joins us every Friday to do the same thing again. So everyone, thank you so much for tuning in, and we'll catch you here next time. Thank you for tuning in to Computer America. Until next week, have a good one. Bye everyone.